Okay, so till now we have seen at one of the technique which we use in bottom-up parsing, and that is called as shift reduce parsing. In while going through the shift reduce parser, we have seen that the most important task or decision we need to make in a shift reduce parser is to decide when we need to shift and when we need to reduce. Okay, now to do that, what we have seen is we created something called a stack. Okay, stack of symbols. So let me draw it. So so we have a stack which contains the grammar symbols, which can contain the grammar symbols, and we have seen that every shift action implies we push the symbol into the stack. Okay, and every reduce action implies you you pop the symbols from the stack, try to match those symbols to one of the RHS of a production, and then the will push the left hand side non-terminal of that production back into the stack. Okay, now this this overall thing, I can say that the uh, to uh, to do this means to decide when to shift and when to reduce, we have introduced the concept of a handle. Okay, and this handle is nothing but it is a substring, it is a string of grammar symbols. Okay, which when present on the top of the stack tells me that I need to go for a reduce action. Okay, that means when we find a valid handle on the top of the stack, we have to go for reduce action instead of shift. Okay, we claim that. Now, matching a valid handle in the stack is nothing but we can translate that into a DFA problem, where I have certain states and the accepting state is encountered in that DFA when we match a valid handle in the stack. Okay, so let us see the overall architecture. So I have an input string. So any input string of terminals, okay, is represented by this. Suppose I can say it as an input tape. Then there is a tape head which is governed by this LR parser, LR, or I can say shift reduce parser. Okay, then I have a stack of states. Okay, and suppose my states are numbered, means 0 3 4, means like this, 6, like this it is numbered, and the stack pointer points to, always points to the top of the stack. Okay, now based on the current state, which is nothing but the top of the stack, and the current tape head, which is nothing but points to the current input symbol I am scanning, I made certain decision or action, and that action is provided by a table called as action table. Okay, there is another, there is also another table called as goto table. Okay, I will explain what does this mean. And using this table, this two table, the current state and the current input symbol, parser makes certain analysis, and all this process continues till the tape reads the final string, and it terminates when it accepts this input string when the stack contains only the starting non-terminal s. Okay, then only it generates the acceptance. Otherwise it rejects and gives syntax error. Okay, so this is the overall architecture of a LR or shift reduce parser. You have a stack of states, you have a input tape containing the input string, you have two tables called as action table and goto table. Based on the current state and the input tape, I try to figure out what is the current action I need to take. Okay, whether I need to shift or whether I need to reduce or whether I need to accept or whether I need to reject. Okay, and on the basis of that, this procedure continues till I reach the end of the input string. Okay, now let us see in more details the architecture of, means what this action table contains. Okay, so for every current state and the current input symbol, okay, I can make certain action. What these actions are? So action table contains the following action. First is, I can say that shift M, S-H-I, shift M. What does this mean? This means on reading the input symbol, on reading the current input symbol, you push state M into the stack. Understood? There is another action called as reduce N. This means you go for reduction, that means reduce by rule number N. What does this mean? So it has certain sub actions. Okay, so reduce by rule number N means what? First, if rule number N, I'll say it contains three grammar symbols in the RHS. Okay, then pop three states from the stack. First thing you need to do, that is to pop the number of states equal to the number of grammar symbols present in the RHS of rule number N. Okay. Secondly, then whatever is the current state, that means whatever state the current stack pointer is pointing to, okay, so based on the current state after popping action and the LHS of rule N, okay, whatever non-terminal it has in the left hand side of rule N, you look at the goto table, okay, and push the state, okay, look for the state present in the goto table in that. So goto table also is a two-dimensional map. So it is a goto table where you have current state and in the row side you will have the LHS non-terminal. Understood? Or you can say in the other way, LHS non-terminals, and in the left hand side you have current state. On the basis of that, whatever is the entry, table entry in the goto table, you push that state into the stack. Okay, so goto table contains, every entry in the goto table contains the state, whereas every entry in the action table contains these actions, shift M or reduce N, like that. The third action is the acceptance state. Acceptance state means what? you need to stop parsing further and you need to accept the string. Okay, that means it will enter the final acceptance state input string. And fourth one is no acceptance. That means you reject the string then and there. Okay, so basically the action table contains these four actions. Either you shift by M, which means you push the state M into the stack by reading the current symbol. You reduce N, that means you have to reduce by the grammar production number N. And in that production, if that production has has suppose X number of symbols in the RHS, you have to pop from the stack X number of times. Suppose you have in the stack, you have less number of states than X, then you have to give a syntax error. Okay. Now based on the current state and the LH after the popping action and the LHS of rule N, we look at the goto table and find out the state which need to be pushed back into the stack. Okay. Now this action continues. Okay, this shift M reduce N, shift M reduce N continues till, by looking at the action table, continues till we complete the scanning of the entire input string. Okay, and till the stack reaches the starting non-terminal, we go to the accept state. Okay, now let us see an example. Now in this example we have 5 rules of a grammar or 5 productions of a grammar. Now you can see the action and go to table is provided. Okay. Now suppose I need to parse 1 plus 1. Okay. How will you do that? So initially the tape head points to 1 and the current state of the stack will be what? Will be suppose state 0. Starting state, we start with state 0. Okay. Now state 0 and the current input symbol 1 corresponds to this let me corresponds to S2. Okay, in the action table, this one. Okay, now this S2, so that means what? I need to push shift state 2 into the stack. Understood? Now based on the state 2, okay, and I need to move the tape pointer. There will be plus now. Okay, now as soon as I find plus and state number is 2, I go for reduce by rule 5. So what does this rule 5 implies? This implies rule 5 means b equal to 1. So the RHS contains only one grammar symbol, that is 1. So you pop the one state from the stack. So the new state will be now 0. Okay, and the LHS of this rule is b. So you look for b and 0. Understood? In the go to table. In the go to table, you look for 0th state, and when the starting non-terminal is b, then what will happen? So 0 and b is state 4. So you will push the state 4 into the stack. Understood? Now this 4, now again you will check this 4 is, you are in state 4 and the current input symbol is plus. Okay, so what will happen? So 4 and plus, you will go for reduce by R3. Okay, now what it will happen now? So R3 means what? Rule number 3, that is E equal to B. So you will again pop the state 4 from the stack. Okay, so now the grammar go to table, you will see for 0 and the LHS is E, so you will have state 3. So you will push the state 3 into the stack. Okay, in 3 what will happen? In 3 you will see that for plus it is S6. Okay, so S6 means you push the state 6 into the stack and move the tape head. Okay, input tape head. So reduce action will continue till it hit a shift action. Okay, or it hit a starting non-terminal. Okay, then only it will stop. Okay, we are continuously reducing. So we first reduce by this. I found that then you have to in from the action table I found that okay, from the current stack pointer, that is state 4, and the current input symbol, that is plus, I have to do another reduction, that is R3. Okay, so in this way we continue the shift reduce parsing. We perform this shift reduce parsing by looking at the action table and the go to table. Okay, now this action and go to table combiningly is called as LR parser table. Okay, so in the next class we will look at how we create this action and go to table. Okay, thanks.